For the past few years, it feels like all we've really talked about in AI is predicting the next word, right? But something really interesting is starting to happen. A whole new class of AI is bubbling up. And these systems, they're not just predicting language anymore. They're predicting the consequences of actions. In a way, they're learning to imagine.
So that's the big question, isn't it? How on earth does an AI learn to imagine? I mean, how do you even build a machine that can dream about what might happen next? Well, that's exactly what we're going to dive into right now. Okay, so here's the main idea, the big takeaway we're going to explore today. You've probably heard of all these different approaches, right? Things like Dreamer, JPA, active inference. It sounds like a bunch of competing teams, all trying to solve AI. But what if I told you they aren't really competing at all? It turns out they're all just using different words, different vocabularies, to describe a solution to the exact same fundamental problem.
All right, so to see how they all connect, we've got to start with the problem they're all trying to solve. And it's not just an AI problem, it's the core problem of intelligence itself. I mean, for you, for me, for any thinking thing. And it really boils down to these 3 steps. First, you have to take everything you've ever experienced and squish it down into a useful summary of how the world works. We'll call that a belief state. Then, using that belief, you predict what's going to happen if you do different things. And finally, you pick the action that leads to the future you actually want. That's it. Compress, predict, act. This is the blueprint for intelligence. Okay, so with that blueprint in mind, let's see how different fields ended up with their own unique lingo for tackling this exact same problem. And we'll start with the one you've probably heard the most about. Right, reinforcement learning, or RL. In the world of RL, that idea of a preferred future is super simple. It's just a reward, a number. The whole game is about figuring out a strategy, what they call a policy, that racks up the highest possible score over time. Let's think of this as our starting point, our baseline. And this is where things get really cool. Let's bring in another idea, this one from neuroscience, called active inference. Now, on the surface, it looks totally different from RL. But if you look closer, it's basically the same math, just flipped on its head. It's like a coordinate transform. Instead of chasing rewards, an active inference agent tries to minimize surprise. It wants the world to match what it expects to see. And look at this mapping. It's almost 1-to-1. The reward in RL is just a preferred sensory state in active inference. Value becomes model evidence. Policy optimization becomes inference. It's the same ideas, just wearing different hats. Okay, so that's the theory. But how do you actually build the stuff? How do you engineer a machine that can literally dream up possible futures? Well, for that, let's take a look under the hood of a really influential model called Dreamer. The heart of Dreamer is something called a recurrent state space model, or RSSM. And it has this really clever way of dealing with the fact that the future is, well, uncertain. Think of its belief as having 2 parts. One part is the solid, reliable memory of how things work. That's the deterministic bit. The other part is like a cloud of possibilities, the stochastic bit, that captures all the different ways things could unfold. It's how the model juggles what it knows for sure with what it has to guess. And this setup enables this incredible learning loop. First, it learns a model of the world from real experience. But then, and this is the absolute game changer, it just starts practicing in its own head. It runs millions of simulations, basically dreaming up futures, and uses those dreams to train itself to be better. It's like a flight simulator for action. This means it can learn so much, so fast, without needing tons of real-world data.
Now, as you can imagine, all this dreaming takes a ton of computer power. The early versions were kind of slow because they had to think one step at a time, but that's where new architectures like Drama and Mamba come in. They're basically new plumbing that lets the system think about many things in parallel, making it way faster and more scalable. And the key thing to remember here is that this is an engineering breakthrough. The core idea, the main goal, that hasn't changed at all. We're just getting better at building it.
Okay, but this brings up a really interesting question. Dreamer works by trying to perfectly reconstruct the future, pixel by pixel in its imagination. But do you really need to do that? What if you could get the gist of the future without having to paint a perfect picture? And that's exactly the idea behind JPA, the Joint Embedding Predictive Architecture. And the difference is huge. Dreamer tries to predict future pixels. JPA, on the other hand, tries to predict future meaning.
It doesn't care about the pixels. It cares about the abstract idea of what's happening.
By working in this abstract space, JIPA focuses on what really matters, the underlying structure of the world, the physics of it. It learns that if you drop a ball, it falls. It doesn't waste a single cycle trying to predict, say, the exact pattern of leaves rustling in the wind or the precise ripples on a pond. It gets the important stuff and ignores the fluff. And that, of course, is way more efficient.
Okay, so we've got all these pieces on the board, right? We've got RL, Active Inference, Dreamer, JEPA. They all sound so different. But now we get to the punchline. We're going to see how all of these roads lead back to the exact same place. So you might be looking at all this and thinking, okay, so which one is going to win? Is it a competition to see which lab builds AGI first? But maybe that's the wrong way to look at it entirely.
And this table, right here, this is the proof. This is basically our Rosetta Stone. Look at it. RL wants to maximize reward. Active Inference wants to minimize free energy, which, as we saw, is just a different way of saying the same thing. Dreamer maximizes rewards inside its imagination. And JEPA minimizes prediction errors to get a good representation so it can then do RL. Do you see it? They're all climbing the same mountain, just starting from different sides. It's all the same optimization problem.
Okay, a quick but important detour. Where does something like GPT fit into all this? Well, the difference is actually pretty simple. A transformer is a master of language. It predicts the next word. A world model is a master of causality. It predicts the next state of the world. One is a storyteller, the other is a physicist. They're solving different but complementary problems.
So, let's bring it all home. When you zoom out and look at all these different fields, you don't see chaos. You see convergence. You see a single blueprint for intelligence emerging. And it has these three parts we started with. Something to compress the past into a belief, an imagination engine to simulate the future, and a way to decide what kind of future you want.
And that brings us to the most important takeaway of all. Yeah, these models have their differences. They handle uncertainty differently. They calculate errors in different places. Some try to reconstruct pixels and some don't. But those are details. Mathematically, they are all, without exception, solving the same control as inference problem. So what does this all mean? It means the arguments you see online about which approach is better are kind of missing the point. The difference isn't foundational. It's philosophical. It's about engineering choices and taste. And realizing that everyone is actually building the same thing, well, that is how you get a real handle on where all of this is headed.